Hello everyone and welcome to the third video on data communication and networking for the Advanced Level ICT subject. I am Sanjay Bershmans, and in the previous video that we released, we talked about how to identify different classes of IP address in classful addressing. We saw how we can identify them using either a binary notation or by using a dotted decimal notation. In this video, we will be talking few things about the classful addressing, ranges of IP addresses, and the main topic for today would be subnetting. So let's get on with the video. IP ranges of classes. So I'm going to put this down in this particular table. So I have the class mentioned in the first column, the starting address of an IP address in that particular class, the ending address of that IP in that class. So let's see for class A. The class A, the starting address would start with all zeros. So the IP address of class A would start with all zeros, and we know the range of class A is from 0 to 127. So the ending address should be 127.255.255.255 because that will be the last address of 127 that you can see. If I want to represent the same figures in binary notation, for the first or the starting class, the binary notation would look like this, and the ending class, the binary notation would look like this. You can notice that I have made the first digit 0 in red to indicate that in binary notation that is a way of identifying the class, so I am using red to denote that. Let's look at class B. In class B, if the ending of class A is from 127.255.255.255, the starting address of class B should be 128.0.0.0, and the ending address of class B should be 191.255.255.255. If I want to represent them in binary notation, it would look like this. You can see still see again 1 0 is a pattern of identifying class B. In class C, the starting address would start with 192.0.0.0 and end with 223.255.255.255, and the binary notations would look like this. Class D, 224.000.239.255.255.255, and the binary notations would look like this. And class E, 240 to 255.255, that would be the last address that you can find in IP version 4, and the binary notations would look like this. So this is how basically the IP ranges of classful addressing would look like. So any address coming between 0.0.0 to 127.255.255.255 would be a class A address. So any address that is coming between 128 to 191, all of those addresses would be belonging to class B. And the ranges, according to the ranges, we can find out what class an IP address belongs to. Classes and blocks. Now, what do you mean by a block? Block can be considered as a network. So now what we are going to discuss is, according to each class, how many blocks or how many networks can be created in each of these classes. So let me give you an example for these blocks using this diagram. Let's say this is a school where we are going to have a number of classes according to the size of the school. So depending on the size of the school, I can have different sizes of classrooms inside this school. Now, in each of these classes, depending on the size of the class, I can allocate the number of students who can accommodate in each of these classes. So this is an example of how networks are created in different classes. If I consider the school as a class, according to the size of the school or according to the size of the class, we can determine how many classrooms or how many networks I can create using that particular class. After creating this class, how many hosts can be supplied with in each of these classes or in each of these networks can be determined. So this number of students in this example is showing you the host numbers in each of the network created by the class. So let's look at these classes and blocks in different networks. Before going into the calculations, we have to remind you about the formulas that we are going to use to calculate each of these values. The number of networks is calculated by the formula 2 to the power number of network bits. So we studied when we were talking about subnet masks that the subnet mask is going to divide the IP address into number of network bits and number of host bits. So 2 to the power number of network bits will give you the number of networks. And the number of hosts will be calculated as follows, that is 2 to the power number of host bits minus 2. We know this minus 2 is because the network ID and the broadcast ID should be taken off in order to find out how many hosts can be created in each of the network. Okay, now let's look at the first class, that is class A. If you look at the table below, the subnet mask, we can divide it with using this line. Bits in green will denote the number of network bits and the blue ones will tell you the number of host bits. But we know, according to the binary notation, the first bit of the class A is always a 0. So we eliminate that part and take the rest of the ones when we are calculating the number of networks. So the number of network bits here will now be 7 and the number of host bits will be 24. So according to the calculation, 2 to the power 7 will give you 128 networks and 2 to the power 24 minus 2 will give you 16,777,214 networks in each of the 128 networks that we have created. So in class A, I can create 128 networks and in each of these network I can put up to 16 million users or 16 million hosts. Now if you consider class B, I have to move this line to this area so that I can separate the network bits and the host bits. Here I know there are 16 network bits and 16 host bits in class B. And since I have a 0 there, I am eliminating 2 bits from the network. I am left with 14 bits for network and 16 bits for the host. And in this, you can clearly see that 2 to the power 14 will give you 16,384 networks. And in each of these networks, I can create 65,534 hosts or end users. Then in class C, I have a subnet mask of 255, 255, 255 and 0, which is denoted in green and blue there in the first row, and 3 bits I'm going to use for the identification, and the rest I will take for the class or the network formation. So in class C, I have 21 bits for the network and 8 bits for the host. So I can create 2,97,152 different networks and 254 users for each of these networks. Now, if you see from class A to class C, the number of networks that can be created increases from class A to C. So that means when the number of network bits increases, the number of networks created increased, and the number of hosts per network decreases as we go down the line. In classful addressing, we have certain disadvantages. If you see in class A, the class A is too large for any organization. Why? In each of the network, out of the 128 networks that we have created, in each of these networks, there are 16,777,216 users. But let's say a multinational company or a big organization is having about 2,000 employees who are going to use different IP addresses. Now to each of these person, if I am giving an IP address, out of this 16 million, I am using only 2,000. The rest of the IP addresses, because it belongs to the same network, cannot be used by any other people, but it is wasted there. If you see in class C, we have a maximum of 254 users in one network. But for larger organizations, sometimes it may not be enough. So the class C most probably will be too small for large organizations. So if they need to get a network, they might have to get 3 different networks of class C in order to fulfill their needs. All these networks usually are going to be wasting IP addresses because they are either too large or they are too small for large organizations. Now if I am using a home network, most probably I might need 5 or 10 IP addresses to use in my home network. Maybe for my iPad, smartphones or laptops, desktop computers. I can use different devices with different IP addresses in my network, but if I am getting a class C address, I have 254 different IP addresses that I can use, but I am having only 10 devices. Whereas I am going to waste 244 different IP addresses. So the main disadvantage of classful addressing was that in classful addressing, we are going to waste a lot of IP addresses. In order to overcome the depletion or the reduction and give more organizations access to the internet, classless addressing was implemented. So because of these disadvantages that we had in classful addressing, we had so many disadvantages of wasting a lot of IP addresses. Because of all these disadvantages, they introduced something called classless addressing. In this scheme, there are no classes, but the addresses are still granted in blocks. Now, we are going to follow the same concept here, but we are not going to call them by different classes. We are not going to separate these addresses into different classes. So we will be using the blocks that was created, but in these blocks we will be creating smaller networks. We will see how that happens. When we are talking about classless addressing, we have to know what a CIDR notation is, or we call it the CIDR notation. In classless addressing, this is also called a slash notation. Either we call it a CIDR notation or a slash notation. This notation is used in classless addressing as well as classful addressing. So the main purpose of CIDR notation was for classless addressing, but it is no harm in using this in classful addressing as well. This notation tells us how many network bits are available in a given IP address. Now let's look at this example. I have an IP address. It says 192.168.54.10/28. This slash 28 is called the CIDR notation or the slash notation. What this is telling you is, or the particular IP address has 28 network bits in it. So the slash CIDR notation is going to tell you how many network bits are available in that particular IP address. Now you might think that we have a default subnet mask for each of the classes. So each of these classes, if you have a default subnet mask, we know the definite number of network bits. So why should we write it down separately in CIDR notations? In CIDR notation, you can see this particular IP address that we were looking at is a class C IP address, which should have 24 bits for networks. But here we are using 28 bits, which will indicate that this is not a classful address, or this is a classless addressing method. So the subnet mask or the default subnet mask will change according to the user's needs in classless addressing. Now we are moving on to our main topic for today, that is subnetting. Since classful addressing method was a failure due to the wastage of addresses, subnetting was introduced. So in subnetting, what we do is we divide the large network provided by the classes A, B, C into smaller networks called subnets. We'll see how this happens. Now let's look at the same example that we saw earlier. To give you a reminder, this school represents the class, the classrooms represent the networks that was created in each class, and the students represent the number of hosts in each of these class. Now in a classless addressing or in subnetting, what we do is we take one of these addresses or one of these networks given by one of the classes and then divide this address into several other networks, and all these small networks that was created is called a subnet. So this is called subnetting. Let's see how subnetting is done for class A. To make more subnets in class A, bits from the host parts are borrowed and the subnet mask is changed accordingly. Now in subnetting, what we are going to do is we are going to borrow bits from the host side and add it to the network side. The number of subnet created is calculated using the formula 2 to the power number of bits borrowed. So how many small networks or how many subnets can be created is calculated using this formula, that is 2 to the power the number of bits that are being borrowed. Now let's look at the example for class A. I'm going to put this into a table. In the table we have the columns network bits, subnet mask, bits borrowed, host bits, subnet and the host. Now these figures are of course very familiar to you because they are the default numbers that was discussed in classful addressing. So the number of bits for the network would be 8. The subnet mask is the default subnet mask that we have for class A. We haven't borrowed any bits yet. The host bits will be 24 and only one subnet can be created, or that means only one network is created. Now let's say I borrowed one bit from the host side. I have indicated that in red here. It says now the number of network bits became 9. 8 plus 1 becomes 9. So if you are writing the decimal notation of this, the subnet mask would now change to 255.128.0.0. And I have borrowed one bit, that is one bit here. And the host bit now, it was 24 earlier, because I borrowed one bit, the host bit now becomes 23. So we know the subnets, number of subnets created is equal to 2 to the power number of bits borrowed. So 2 to the power 1 will give me 2. And the number of hosts is calculated by 2 to the power 23, that is the number of host bits, minus 2, which is going to give me this value. Let's borrow another bit. Now the bits borrowed would be 10. My subnet mask changed to 192.192.0.0. Number of bits borrowed would be 2, indicated in red in the subnet mask below. And the host bits is now 22. The number of subnets that can be created is 2 to the power 2, which is 4. And the number of hosts created is reduced to 4 million now. If I borrow another network bit, that is the subnet mask would be 255.224.0.0. Then the bits borrowed will become 3 now, host bits 21, subnets created is 8, and number of hosts created would be 150. Like this, for class A, I can borrow one by one the bits from the host side and reduce the number of hosts until we get the value 2. So I can borrow them until I get a value for 2 for the number of hosts. In any class it would be the same. Let's see for class B how this works. The default subnet mask for class B starts with 255.255.0.0. We haven't borrowed bit yet, and the number of hosts that was created was 65,534 as the classful addressing. I borrow the first bit. Now the subnet mask changed to 255.255.128.0. The number of bits borrowed is 1, and now the host bits became 1 less than the one we had earlier, and subnets 2. And another bit is borrowed, and the values will go on as follows. In the same way, I can reduce the number of hosts until 2 in the class B subnetting section as well. So this is how you are going to reduce the number of users using subnetting. So in subnetting, these calculations are very crucial. So you have to know the formula of how to calculate the number of networks, how to calculate the number of hosts per network, how to calculate the number of subnets that can be created in each of the networks. So with this section, I will end this video, and in the next video we will be considering about further subnetting, and we will talk about different examples of subnetting that came for your examinations. So we will wind up the video for today. Until I see you in the next video, this is Sanjay sir signing off. Take care and God bless you.